Hello students, how are you all? I hope you are doing absolutely good. So welcome all of you at AriserTalent, and we have started our chapter, that is electricity, from your class 10 physics, and until now we have discussed that about the Ohm's law. So Ohm's law generally give you a basic description about the relationship between V, I and R, and we have also seen that some of the devices will follow the Ohm's law while the others do not. So the devices which are going to follow the Ohm's law are known as ohmic devices, and the devices which are not following the Ohm's law is known as the non-ohmic devices we have. Now today we are going to discuss about few of the terms that will relate to our Ohm's law, that is about the resistance and resistivity, and then after we will see a combination of these resistances in series and parallel. So let's start with the resistance now. So our today's topic is all about resistance and resistivity. Resistance. Now this is a very general term you have heard about. Resistance means to oppose something. अगर किसी चीज़ को हम स्टॉप कर रहे हैं या किसी चीज़ को हम अपोज कर रहे हैं तो उसके लिए हम टर्म यूज़ करते हैं उसको रेजिस्ट करना. इट मीन्स इट इज़ अ रेजिस्टेंस वी हैव. So in any circuit the current is flowing because of the availability of the free electrons, but if a current is flowing in any metallic conductor there will be some positive ions too. These positive ions will going to continuously collide with the negative ions present in the circuit, and they will reduce the speed of that free electrons. If the speed of the free electrons will reduce, we can say that it is the resistance of the circuit, because they are providing the stoppage in the flow of electrons. It means they will resist their activity. So this phenomena is known as the resistance, and this is a basic term we have also discussed about in the Ohm's law. अगर हम किसी सर्किट की बात करें तो सर्किट में कोई भी कंडक्शन, इलेक्ट्रिसिटी का कंडक्शन क्यों हो रहा है? क्योंकि उसके अंदर फ्री इलेक्ट्रॉन्स अवेलेबल हैं. लेकिन अगर हम मेटालिक कंडक्टर की बात करें तो उसमें फ्री आयंस के साथ हमारे पास पॉजिटिव आयंस भी हैं. अब होगा क्या? सारे पॉजिटिव और नेगेटिव आयंस सिस्टम के अंदर एक दूसरे से कोलाइड करेंगे और पॉजिटिव आयंस क्या करेंगे? नेगेटिव आयंस की जो स्पीड है, इट मीन्स इलेक्ट्रॉन्स की जो स्पीड है किसी भी कंडक्टर में, उसको स्टॉप करने की और उसको रिड्यूस करने की कोशिश करेंगे. इट मीन्स जो एजेंट या जो हमारे पास में कैरियर है वो फ्लो ऑफ इलेक्ट्रॉन कर रहा है, वो कंडक्शन का काम कर रहा है, तो पॉजिटिव आयंस क्या कर रहे हैं? उसकी एक्टिविटी में रेजिस्टेंस डाल रहे हैं. इट मीन्स वो उसकी एक्टिविटी को स्टॉप कर रहे हैं. तो दिस इज टर्म्ड एज अ रेजिस्टेंस वी हैव. नाउ resistance basically is a ratio of V upon I that we have discussed in the Ohm's law. So it is the stoppage or reduction in the flow of electrons. It is in general term, it is the stoppage or reduction in flow of electrons, or in other terms we can say that resistance will be the ratio of V and I. It means potential difference applied across the ends of any conductor to the current, and in general we can also write it as R is equal to V upon I. This is the topic we have discussed earlier. And can you tell me what will be the value of resistance? What is the unit of resistance here? The unit of resistance will always be in ohm, and in the terms of the physics we will call this symbol as a omega. So its unit is ohm, and it is represented by the symbol like this, and this symbol is termed as omega we have. So this is all about the resistance we have. Now the resistance of any circuit is going to depend upon a number of factors we have. So it will be directly proportional to someone, it will be inversely proportional to someone, and it will increase or decrease according to the some factors we have. So let's discuss about the factors on which the resistance of a circuit depends. what will be the factors on which the resistance of a circuit depends upon? So usually there are 4 factors on which the resistance of a circuit is going to depend, and these 4 factors we have. The first factor is about the length of the conductor we have. So the first factor is about length of conductor. Second will be the resistance of a circuit also depends upon area of conductor. Third factor will be temperature of a substance. And the fourth and the final factor will be nature of material. The nature of material is always going to specify whether the resistance will be high or low. So it is also depends upon nature of material. So these are the factors on which the resistance of any circuit depends. First is length of the conductor, second area of conductor, third one is temperature, and fourth one is nature of material we have. Now let's deal with all these factors one by one. So firstly, consider the length of a conductor. What will be the effect on resistance according to the length of the conductor? If you are going to increase the length of a conductor, the resistance of any circuit will also going to increase, because resistance is directly proportional to length of the conductor. As long as the length of a wire is increased, the resistance will also going to increase. If you double the length of the wire, the resistance will automatically going to be doubled. It means these two factors are directly proportional to each other. So first factor we have is length of a conductor. So resistance of any circuit is directly proportional to length of any wire or conductor we have. So resistance will be directly proportional to the length of the conductor. So resistance will be denoted by R, and it is directly proportional to small l. Small l we have is the length of the conductor. It means if the length of the conductor is increased, resistance will increase. If the length of the conductor is decreased, resistance will also be decreased. So this is about the direct relation. Now the second point is about area of conductor. The resistance is inversely proportional to area of conductor. So resistance will be inversely proportional to area of conductor. It means R will be inversely proportional to area. Now what will happen? if area increases, resistance decreases. If area decreases, resistance will increase. You can see that area and resistance are inversely proportional. It means if you are going to double the area, the resistance will be half. अगर हम इस केस में एरिया को डबल कर दें तो रेजिस्टेंस सर्किट का क्या रह जाएगा, हाफ रह जाएगा, क्योंकि इन दोनों के बीच में क्या है, इनवर्स रिलेशन है. तो ये दो फैक्टर्स हैं जो कि हमें बताते हैं कि रेजिस्टेंस बेसिकली किन किन चीज़ों पे डिपेंड करता है. लेंथ ऑफ द कंडक्टर से वो डायरेक्टली प्रोपोर्शनल है और एरिया ऑफ क्रॉस सेक्शन से वो इनवर्सली प्रोपोर्शनल है. नाउ what are the other two factors we have? We have other two factors about temperature and nature of material, but firstly copy it from here so we can proceed to our next part. Now let's move to the third factor we have. The third factor is about the temperature. Now, what has the temperature has its effect on the resistance? If I am talking about the pure metals, in case of the pure metal we have, the resistance of the metal will decrease on increasing the temperature, but in case of the alloys it will show a slight increment. So we can say that if the temperature is going to be increased, for the semiconductors the resistance will increases, but for the metals the resistance will going to be decreased, because on increasing temperature, in case of the metal, conduction increases. So conduction and resistance are opposite to each other, so the resistance will going to be decreased. So I can write it as, in case of pure metals, if we are going to increase the temperature, resistance will decrease. But if you are talking about semiconductors, if temperature increases, resistance also increases. So this is the criteria about the temperature dependence on the resistance of a substance. Now let's move to the last factor we have, that is about the nature of material. That is about now, how will the nature of material decide the resistance of any conductor? Suppose I am using copper, magnesium and some of the metals we have like gold, etc. So the resistance in case of these metals will be very low. But if I am using nichrome, constantan, carbon, these are actually the semiconductors or the alloys we have. So in this case the value of resistance is bit high. That's why you can see that in case of the electrical ovens, electrical toasters and in some of the apparatus in our homes, we are using the nichrome wires. Why we are using the nichrome wires? Because they have the high value of the resistance. So in case of pure metals, whether it may be of the copper, whether it may be of aluminium or gold, the value of resistance is low. But if we are using nichrome, constantan, these will have a high value of resistance. These are actually our alloys or semiconductors, so these will have a high value of the resistance. So जो हमारे घर में इलेक्ट्रॉनिक अप्लायंसेस हैं लाइक इलेक्ट्रिकल ओवन, इलेक्ट्रिकल टोस्टर, इलेक्ट्रिक हीटर, यू हैव सीन दैट इलेक्ट्रिक हीटर के केस में जो रोड होती है मेटालिक, वो जल्दी से रेड हॉट हो जाती है। तभी हम देखते हैं कि कुछ ही टाइम में क्या होता है, जिस रूम में हम रूम हीटर को प्लेस करते हैं वो बहुत जल्दी से हमें वार्म प्रोवाइड करता है। वो क्यों करता है? क्योंकि उसका जो मटेरियल है, इट मीन्स जो मटेरियल वहाँ यूज़ हुआ है वो कौन सा मटेरियल है? नाइक्रोम। नाइक्रोम मटेरियल है, वो बहुत ज़्यादा रेजिस्टेंस प्रोवाइड करेगा, तो इसकी वजह से क्या होगा, इसको हम यूज़ करते हैं फॉर मेकिंग इलेक्ट्रिकल ओवंस, इलेक्ट्रिकल हीटर्स एक्सेट्रा। सो ये कुछ फैक्टर्स थे जिन पे किसी भी चीज़ का रेजिस्टेंस डिपेंड करता है। तो हमने ये देखा कि अगर हम लेंथ ऑफ कंडक्टर इंक्रीज करेंगे तो रेजिस्टेंस इंक्रीज करेगा। एरिया के वो इन्वर्सली प्रोपोर्शनल है, एरिया को अगर हम इंक्रीज करेंगे तो रेजिस्टेंस डिक्रीज करेगा। थर्ड फैक्टर था हमारा टेम्परेचर, प्योर सब्सटेंस के केस में इंक्रीज करने पे डिक्रीज करेगा और सेमीकंडक्टर्स के केस में टेम्परेचर इंक्रीज करने पे रेजिस्टेंस भी इंक्रीज होगा। और नेचर ऑफ मटेरियल पे भी रेजिस्टेंस डिपेंड करता है। अगर हम सेमीकंडक्टर और अलॉयस की बात करें तो उनके लिए रेजिस्टेंस की वैल्यू ज़्यादा होगी एज कम्पेयर टू द प्योर मेटल्स वी हैव। So these are all our factors which is very important for the dependence of resistance on these factors. Now from this we will have some conclusions here. Now what conclusions we are getting? You have seen that resistance is directly proportional to length of wire or conductor. So what I can write it? I can write it R is directly proportional to L. Second factor, we have seen that resistance is inversely proportional to area of cross section. And I can write it as R is inversely proportional to 1 upon A. So this is our equation number 1 and this is our equation number 2. This is equation 1 and this is our equation number 2. Now what we are doing, we are just combining these two equations here. Now what we are doing, on combining both these equations, we are combining both these equations. On combination of both these equations, we will get that R is directly proportional to L and inversely proportional to A. You can see that we will get a new term here. This is R directly proportional to L and inversely proportional to A. Now again, if I am going to remove the proportionality constant, I have to put a certain constant here. So what constant I am putting here? R is equal to this L upon A. R is equal to this constant and L upon A. Now this constant is known as rho and it is known as the resistivity of a conductor. So this equation we are getting here, we are getting this term, this is known as resistivity of conductor, and this term that we have drawn a P like this is known as the rho. What we called it? We called it rho, RHO. This rho is the proportionality constant here and this is known as the resistivity of a conductor. Now if I am calculating the value of rho from here, what I will get? I will get rho equal to RA by L. This is our new formula for the resistivity. Now this term we are getting here is known as resistivity. Now what will be the unit of resistivity here? Let's calculate unit here. Unit of resistivity. The formula we are getting here is rho equal to Ra by L. R is resistance, A is area of cross section, and L will be the length of the conductor we have. So rho equal to Ra by L. What is the value of resistance and the unit of resistance we have? The unit of resistance is ohm. The general unit for calculating the area of cross section is meter square, and the standard unit for calculating the length will be meter. So you can see that 1 amp will be cancelled by 1 and I am getting here ohm meter, or I can write it as ohm amp. So what we are getting here? We are getting the unit of resistivity here. Don't get confused with the units here because we have a lot of terms and a lot of units. So firstly, the unit of resistance is ohm, but the unit of resistivity is ohm meter we have. So you can derive the units like this. So this is about the resistivity of a conductor we have. Now the resistivity will also be going to depend on the certain factors, and the resistivity of a material will going to tell you whether the material is conductor, insulator or semiconductor. So first of all, copy this from here so we can proceed to the next part. Now one more question arises here. When will be the resistivity set to be 1 ohm meter? किसी भी सर्किट की resistivity 1 ohm meter कब कहलाएगी? When the area of cross section is 1 meter square and the length of a conductor will be 1 meter and the resistance in this case will be 1 ohm, we can say that the resistivity is said to be 1 ohm meter. If all these conditions are 1, 1, 1, we can say that the resistivity will be 1 ohm meter. So let's discuss about the nature of some materials depend upon the resistivity. So the next part is about types of material on the basis of resistivity. Now, before this topic, we have discussed about the type of the material we have, that is about the conductor, insulator and the semiconductor, and that case we have discussed in reference to the availability of the free or valence electron. But how will the resistivity will going to determine about the nature or the type of the material? Again we have the 3 categories. It means अगर किसी सर्किट में या अगर किसी कंडक्टर में अवेलेबल फ्री इलेक्ट्रॉन्स है, इट मीन्स वो कंडक्शन करेगा. अगर वो कंडक्शन करेगा तो वो कहलाएगा कंडक्टर. लेकिन कंडक्टर के केस में क्या होता है, रेजिस्टिविटी बहुत कम होती है, वो रेजिस्ट नहीं कर पा रहा है तभी तो वो कंडक्शन कर रहा है. इट मीन्स द सब्सटेंस विच हैव अ हाई कंडक्टिविटी विल हैव अ वेरी लो वैल्यू ऑफ रेजिस्टिविटी, क्योंकि वो कंडक्शन तभी कर पा रहा है क्योंकि उसमें कोई रेजिस्टेंस हो ही नहीं रहा है. और जिस सब्सटेंस में या जिस भी हम जो भी कोई कंसिडर करेंगे यहाँ पर, अगर उसमें कंडक्शन नहीं है, कंडक्शन ज़ीरो है क्योंकि उसमें फ्री इलेक्ट्रॉन्स अवेलेबल ही नहीं है. अगर कंडक्शन नहीं है इसका मतलब उसकी रेजिस्टिविटी क्या है, बहुत ज़्यादा हाई है. रेजिस्टिविटी हाई है तभी तो वो कंडक्शन नहीं कर पा रहा है. इट मीन्स अगर कंडक्शन ज़ीरो होगा तो उस केस में रेजिस्टिविटी बहुत हाई होगी. तो उस बेसिस पे हमने अगेन मटीरियल्स को क्लासीफाई करा है 3 कैटेगरीज में, दैट इज conductors, semiconductors and insulators. Conductors, semiconductors and insulators. Now, let's discuss the conductors here. Our first category is about conductors. Conductors means they have the availability of the free electrons and the pure metal will going to behave as a conductor. It means in case of the conductors, the value of resistivity is very low. So, conductors have low resistivity and the examples we have in this category are copper, gold, silver, aluminium. So, this is about the conductors. Second category we are discussing is about the semiconductors. Second category we have is about semiconductor. Semiconductors will have a resistivity that is moderately lying between the conductor and conductor and insulator we have. So, it have a moderate value of resistivity. It have a moderate resistivity. If I am talking about the examples of the conductors, we have nichrome, carbon, constantan and magnenin. So, few examples are constantan, manganese, nichrome. So, these are the few of the examples belonging to the semiconductor which is having a moderate resistivity. Now, discussing about the high resistivity material, and the high resistivity material means they will show a zero conduction. They are known as insulators. So, the insulators basically have high resistivity. If they are having a high resistivity, it means they will not going to show any conduction. There will be no passage of electrons from such material. And the examples we have are rubber and plastic. So, conductivity and resistivity are just two opposite terms. The material which are very good conductors, it means their resistivity is very low. So, low resistivity materials are conductor, having moderate resistivity are known as semiconductor, and the materials having a very high resistivity are termed as insulators. So, this is the classification of the materials based upon the resistivity. Now, there is one more term that is about the conductivity. So, conductivity and resistivity are just opposite to each other. It means the material which is having a very high conductivity have a very low resistivity. So, just copy it from here. So, we can discuss about the conductivity we have. Now, having a last term that is about the conductivity which is just opposite to that of the resistivity we have. So, our last term is about conductivity. Now, conductivity is just reciprocal of resistivity, or we can say it is just opposite to that of the resistivity. So, the reciprocal of resistivity is called conductivity. जो टर्म रेजिस्टिविटी की रेसिप्रोकल होगी उसको हम क्या बोलेंगे? कंडक्टिविटी बोलेंगे. अब जो रेजिस्टिविटी होती है उसको हम रो से डिनोट करते हैं, दिस इज कॉल्ड रो. लेकिन जो कंडक्टिविटी होगी उसको हम डिनोट करेंगे सिग्मा से. दिस इज सिग्मा एंड इट इज इक्वल टू 1 अपॉन रो. अब हमारे पास रो का क्या फॉर्मूला होता था? RA बाय L. तो अगर हम इस फॉर्मूले को जस्ट अपोजिट कर दें, इट मीन्स सिग्मा विल बी इक्वल टू L अपॉन RA. दिस विल बी द फॉर्मूला. So conductivity is just opposite to that of the resistivity. This is our resistivity, this is our conductivity, and it is denoted by the symbol sigma. अब यूनिट क्या होती है कंडक्टिविटी की? रेजिस्टिविटी की यूनिट होती थी हमारे पास ओम मीटर, तो कंडक्टिविटी की यूनिट होगी ओम इनवर्स मीटर इनवर्स. ओम मीटर इज a unit for resistivity. So for the conductivity we have a unit ohm inverse, meter inverse, or ohm inverse or meter inverse in a short form known as Simon. So this will be the unit of conductivity we have. So the unit of conductivity is known as Siemens, or we can say that ohm inverse, meter inverse. So this is the conclusion we are getting from here. So we have studied about the four terms here: conductance, resistance, conductivity, resistivity, and conductance and resistance are opposite to each other, and conductivity and resistivity are just opposite to each other. So don't get confused between the terms, their identification, their formulas, and the most important, these all have a very different units. So this lecture is over for today. We will deal with many more topics in our next lecture. Thank you so much and have a nice day.